Okay, so it's been over 2.5 years since OpenAI introduced Whisper, which was their speech to text model. And while it was fantastic, and it was also their sort of last main open weights release model, they've updated it a couple of times over the past 2 years, but we certainly haven't seen them open their latest version of the speech to text or the text to speech voices, etc. So this has definitely been the de facto standard for ASR that people have been using. And while most people perhaps haven't been using the exact version that OpenAI released, people have been using either the Distil-Whisper from Hugging Face, or even things like I personally use the MLX version of these models so that I can run it fully locally on my Mac. Now, while we've been waiting for OpenAI to release something new, out of the blue, NVIDIA has just quietly released the weights to a model called Parakeet. Now, the Parakeet models are not something new. The original one came out last year, but it was still quite on the big side, and it perhaps wasn't the sort of whisper killer that everyone had hoped for. As of last week, they've released Parakeet version 2. Now, this is a much smaller model, so this is just 0.6 billion or 600 million parameters. And it can not only do fully automatic speech recognition, but it can do things like give us accurate word level timestamps. It can predict punctuation, capitalization, a whole bunch of things. And it turns out that its word error is actually better than Whisper. So the one downside of this is that it's only for English, or at least the version that they have currently released is not a multilingual version. So if you've got something that's multilingual, Whisper is still probably the way to go. But if you're looking to do really fast transcription of English language recordings, then you should definitely check out Parakeet. So this is up on Hugging Face already. I'm going to go through the code in a second. It's actually licensed so that you can use it for commercial use. And as well as putting the actual model up on Hugging Face, NVIDIA has also released a Hugging Face Spaces where you can actually come and try this out yourself. You can see we can just pick one of the things that they've got there and then transcribe. So surprisingly, there doesn't seem to be a blog post about this or much info about the actual release, especially when it seems like this is actually quite a substantial release coming out of NVIDIA, and something that I think a lot of people are actually going to like to be able to use this for transcription, etc. So if we look at the papers, we can see that there's actually 2 papers regarding this that are actually quite old. So it does seem that this is just sort of a new tuning and perhaps some improvements to the architecture for the original Parakeet model. If we look in at the model card, we can see that it was trained on approximately 120,000 hours of English speech data. So certainly a lot more data than what we've seen some of the smaller open source TTSs have been getting success with recently. Obviously, this is different for speech to text rather than text to speech. But also nicely in what they've actually put up here, they've got links to how you can actually do the inference so that you can actually do long audio files in here. So for me personally, one of the things that makes this really interesting is not just that we can run this model normally, which we'll have a look at in a second in Colab, but already we're seeing MLX versions of this so that you can run this fully locally. Let's jump into the code. I'll have a look at the version in Colab, and then we'll have a look at what's already out on MLX and perhaps what's coming quite soon as well. Okay, so if we come into the code, to basically get this to work, we need to use the Nemo Collections ASR. So you'll see that I've installed that up here. We could install all the Nemo toolkit stuff. I've also installed some utils for just dealing with audio, etc. Once we've got it installed, it's very similar to Hugging Face's transformers. We can basically just load up the model and then it's ready to go. Now we can see in the example here, they've basically given a small WAV file to transcribe. And if you use that file, it will work fine. The only issue is that once you go for something that's bigger than just a few minutes, you're going to run into issues. So you can see here that I've brought in an MP3 file of a talk, which is about 26 minutes long from memory. And if I run that through, I will just basically get an error. And you can see this kind of error is going to be showing us that the shape here is just too long for the model. So we need some way to sort of chop it up. And that's what I put together here, is where it will basically handle everything so that we can instantiate a transcriber. We can then bring in our audio path. It will basically take care of the segments, of adjusting the segments and stuff, and run it through. So if you're using this version, you don't actually need to load the model at the top. This will actually load the model for you. And you'll see that once it's loaded, we can see how many seconds it is in duration. It will take care of converting it from stereo to mono, changing the audio to 16K, etc., and applying the settings for doing a long transcription in here. Amazingly, it does the transcriptions very quickly. So you can see here the 26 minutes of audio basically was transcribed in 25 seconds. It will then save it out as a CSV file, and you can come in and have a look at that. It will also then allow you to visualize the transcript and visualize the different times that things are being said, etc. So if you want to play something back here, I've just brought it in. Again, instantiated the audio transcriber. We're playing back the first 500 seconds. Okay, so you can see that when we come in here, if I started off.
My name's Pat Grady. I'm one of the members of Team Sequoia. I'm here with my partners, Sonia and Constantine, who will be your MCs for the day. And along with all of our partners at Sequoia, we would like to welcome you to AI Ascent.
So you can see that the transcription is very good, right? It's picking up things like names very well. It's picking up where it should capitalize things and stuff like that. And we've got these timestamps on the side here. So this is basically saving it all as a CSV file. Now you could write a script to get that into a normal sort of markdown format or something like that if you wanted to do that. That shouldn't be very difficult in here, but you can see it's gone right through, transcribed the whole thing. So we've got the right through to sort of the end of the file there, over 1600 seconds in here. So if you are looking for something that allows you to basically transcribe audio very quickly, and that audio happens to be in English, I'm very conscious of the fact that this is not ideal, that it's English only and not multilingual. If you've got a multilingual use case, you're probably still better to stick with Whisper. Hopefully, NVIDIA will release a multilingual version of this at some point in the future. Now, if you want to run this locally and you've got a Mac with an Apple Silicon chip in it, you can actually run the MLX version of this. So this will run quite quickly on your Mac. You basically just come in here, set up the project, etc., and then run it. There's some examples in here of how to use it with the Python API. So I'm finding this to be a really good substitute for Whisper, where I'm doing bulk transcriptions of podcasts, of things like that, where I'm basically just generating context to pass into an LLM model. So I don't need it very fancy, and actually having the timestamps in there, the models can handle that quite easily. The one thing that this is missing is nice diarization, is that we don't have sort of diarization to know who is speaking when. And if you go back and look at what I had here, we've got very accurate transcriptions, but we've got no system of knowing who the actual person speaking was. So you could use an external diarization model. That's what I used to use with Whisper. The other option is, of course, you can use a multimodal LLM, like I showed with the Gemini for audio video, where if you basically pass in the speakers, it's actually very good at not only being able to hear the differences in voices, but even to be able to hear when one person refers to the other person by name, and therefore work out who the actual speakers are if you pass in sort of a list of speakers as well in there. So that's still an option that you can use if you need something fancier and stuff like that. For me personally, this is a very interesting model. My guess is we're going to see multiple versions of this. So it can do real transcription where you can basically just automatically pass that into an LLM like an assistant and have something perhaps like Kokoro coming back as a real-time TTS, etc. Anyway, have a play with this. I'm certainly testing it out for a bunch of different things, and I might make some more videos in the future of combining a few of these sort of TTS and ASR systems to show how you can use this for doing sort of live transcription on your own device without having to send anything to the cloud, etc. Anyway, as always, let me know what you think in the comments. I'm very interested to see if people are using this. At the time that I'm recording this, I haven't seen a lot of versions apart from the MLX one. If there are other ones out there, let me know. My guess is that this will be quantized at some point, and we'll get some quantized versions, which are probably going to be even quicker and may not lose a huge amount of accuracy for this. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.